Nginx has become a cornerstone of modern web infrastructure, often referred to as the Swiss Army knife of web servers. With its high performance, scalability, and versatility, Nginx is a critical tool for web developers and administrators alike. Welcome to the Nginx course. My name is Anthony, and I'm excited to guide you through this essential technology. This course is designed to equip you with both foundational knowledge and advanced skills. In the introduction, you'll discover the objectives of this course, the basics of web servers, and why Nginx stands out with its unique architecture and wide-ranging use cases. In the Install and Config section, we'll cover installing Nginx, setting up your first website, and configuring firewalls for secure communication. In the Intermediate Config, you'll set up virtual servers, configure redirects, deploy load balancers, and use Nginx as a reverse proxy. The Security section introduces HTTPS, HTTP headers, and authentication setups, teaching you how to protect your Nginx web server effectively. Finally, in Performance, we'll optimize Nginx using rate limiting, caching content for faster response, compression for faster delivery, and monitoring troubleshooting techniques. Throughout this course, you'll engage in practical labs and exercises to reinforce your learning, ensuring you can apply these skills in real-world scenarios. At KodeKloud, community matters. Join our vibrant forum to ask questions, share insights, and connect with fellow learners from around the globe. Let's embark on this exciting journey to master Nginx. So what is a web server? Web servers are computers running a piece of software that process and deliver web pages to users' browsers when they request them. We interact with the web server on a daily basis. You open up your browser and you type something like KodeKloud.com, and the page automatically displays on your screen. But how does this actually work? The process is the same across virtually every single website. You type in the name of the website, and your browser looks up the IP address of something like, let's say, KodeKloud.com via DNS. Think of DNS like a phone book that has all of the IP addresses for all the websites. The browser then connects to the IP address of that website. This website will have, for the most part, a web server behind it that will receive your request, fetch all the information, homepage, resources like CSS, images, JavaScript, etc., and will send that content back to your browser. Think of the web server like a digital waiter at a restaurant. It acts like a middleman that takes your request and delivers the necessary information so you can view the website. Your browser either uses HTTPS, which is the encrypted protocol, or HTTP, the unencrypted protocol. For the most part, most browsers will forward you to HTTPS, and most websites are running with HTTPS. Now, when it comes to web servers, you have the traditional web servers like Apache, which was introduced back in the mid-90s, and Microsoft Internet Information Server, or traditionally known as IIS, which is also released around the same time. So this many clients to one server might have been common back in the day, but now you have a fleet of servers that would be able to handle this with a load balancer, something that Apache and IIS traditionally were not built for, nor could they perform at that time. Another concern with traditional web servers is the amount of simultaneously connections they can handle at any given time. Traditional web servers like Apache would generate a new process for each coming request. So the more incoming requests, the more requests it needs to spawn, which leads to more CPU and memory usage. These days, we have a lot of options when it comes to web servers. We are obviously going to focus on Nginx, but there are others out there like OpenResty, which is really just an enhanced version of Nginx. We have Lightspeed, we have Caddy, of course we have Apache and IIS. In the next lesson, we are going to begin to understand Nginx, and I'll introduce it to you guys. So what's Nginx? Nginx is a much newer web server that was introduced just over 20 years ago. It's open source, but there is also a commercial-based option, and you can install it in Linux, OS X, even Windows. It was designed to overcome the limitations of older web servers, offering better performance and scalability. But really, it was developed to compete with Apache and IIS, which dominated during the mid-90s. It was also designed to solve a problem in which a web server could handle 10,000 requests at the same time, something that had not been done prior to that. Serving static content is Nginx's best feature because it's easy. By static content, I mean all types of data, text files, pictures, music, videos, all that kind of stuff. Nginx is able to serve that content quite easy. Nginx addressed some of the limitations that Apache and IIS had at that time, like speed, performance, things like asynchronous processing, meaning that a single process could serve multiple requests concurrently. Nginx is able to do that, and a recent benchmark has Nginx being able to process 4 times the amount of concurrent connections than Apache at a much lower latency, using half the amount of resources. Like I said, Nginx comes in the open source community version or the commercial paid version, though you do get some additional features. It's called Nginx Plus. When searching for Nginx, ensure that you're on the right site. So if you're using the open source, stick to nginx.org. And if you're using Nginx Plus, ensure you're using nginx.com. They are similar, but they're different. A 2023 recent survey found that the most popular web server being used today is Nginx with 21%. 32% if you count OpenResty, which, like I said, is an enhanced version of Nginx. That is a third of the internet being served through Nginx. Nginx is only second to Cloudflare when it comes to top million sites and ranked number 1 in most market share computers and domains. And also, Nginx ranks first in market share of computers by a large number, and also ranks number 1 in market share of domains. Again, you can see OpenResty here on the third on the right-hand side. And like I said, OpenResty is just an enhanced version of Nginx. So when you really think about it, it's kind of 2/3 of the market share in domains if you combine Nginx and OpenResty, of course. Nginx is trusted by thousands of companies. Some of the biggest companies in the world like GitHub, Cloudflare, LinkedIn, Microsoft. The list goes on, Netflix. On the next slide, I'm going to be going over Nginx overview and the architecture. Let's begin with understanding the event-driven architecture of Nginx. Imagine this. You walk into your favorite coffee shop and it's packed. People are lined up at the counter waiting to place their orders. Now imagine if the barista had to make each coffee one at a time in sequence before taking the next person's order. The line would be endless. But this coffee shop is smart. They use an efficient system. One barista takes your order and another starts preparing their drinks immediately. And by the time you get to the counter, your coffee is ready. It's fast, non-blocking, and everyone is happy. This is very similar to how Nginx handles requests simultaneously using an event-driven architecture. Unlike the old linear method of handling requests one by one, this event-driven mechanism is also known as asynchronous processing. This approach makes Nginx non-blocking and asynchronous, enabling it to handle very large volumes of traffic with ease. Nginx super fast and ideal for modern web applications where requests can pile up quickly. It's like running multiple cash registers in a busy store instead of having just one. Imagine a busy restaurant where you have a chef in the kitchen preparing the dishes. Now, this chef can only cook one dish at a time, but a busy restaurant means multiple customers. So a waiter takes orders, takes it back to the chef. Once the dishes are ready, the waiter delivers the food to the customers. The waiter doesn't stand by each customer, but instead keeps moving back and forth between the chef and the customers, making sure the food gets to the customers. Now let's translate that to Nginx. Let's break it down into steps. The first step is the incoming request, or in our example, a customer's order. Nginx receives a new HTTP or HTTPS request from a client. Then it moves on to the second step, and that is the event loop, which in our restaurant example is the waiter. Nginx logs the event of the request, writes down the order essentially, then continues in an event loop, constantly checking for new incoming events without blocking the process. This event loop is essentially our waiter going back and forth between the chef. Then it goes to the third step, and that's the processing event, which represents our chef making the dish. If it's waiting on data like a response from a database, it moves on to handle another event rather than just waiting. The chef wouldn't prepare one ingredient at a time. It would be, chopping vegetables while it's waiting for something to boil, something to be ready. And finally, the last step is the response sent. It's essentially our waiter delivering the dish. So once the necessary data is ready, Nginx sends the response back to the client and moves on to the next event. In summary, Nginx takes the incoming request, which is passed to the event loop, where the request will be logged and sent to a third step, which is processing the event. It gathers all the data required and moves on to the last step, which is the response sent, in which the data is sent back to the client. The event loop is key here, though. The event loop will continue to receive requests, log them, and pass them to the processing event step over and over again. Hence the name loop. In our restaurant example, we had one waiter and one chef. In a busy restaurant, we would probably want to have more chefs making the food because, the orders can quickly add up. These chefs are called worker processes in Nginx. And each incoming request is handled by the worker process, which operate within the event-driven model mentioned earlier. The master process oversees worker processes and handles tasks like restarting the workers, assigning configuration. Think of the master process as a supervisor that is overseeing these chefs. Basically, the master is responsible for controlling and managing the life cycle of these worker processes. It doesn't directly handle any incoming request, but plays that supervisor role, ensuring that the workers, the chefs, are running smoothly. When it comes to worker processes, each worker process runs independently and handles connections using an event-driven approach, the one that we just talked about. Multiple worker processes allow for parallel handler requests. So more workers, the more requests you can handle. If it's a busy restaurant, we want a few chefs, but we also need a few waiters to take orders quickly. Each worker process, again, each chef in our example, uses an event loop to manage incoming connections. In other words, each chef has its own assigned waiter. The event loop monitors multiple events simultaneously, such as new connection, requests, data availability, and then processes them as they occur. So now our restaurant has many chefs or worker processes, each with an event loop or waiter to be able to handle multiple requests at a time. Let's talk about Nginx in all its use cases. Nginx can be used as more than just a simple web server. It can be used as a load balancer, a caching server, and a reverse and forward proxy, providing performance and security. So what's a load balancer? Suppose you manage a busy restaurant. Yes, I'm going to be using the restaurant example throughout this course. I do apologize about that, but it's the easiest way to explain a lot of these features that Nginx has. So back to managing this restaurant. there's a lot of customers and they're waiting to be served. If you only had one waiter taking orders and bringing food, the customers would be waiting a lot, and some may grow impatient, even angry. So what do? You could hire a few more people and ask them to share the load. And a load balancer is like the restaurant manager. It makes sure that internet traffic, in this example, the customer's orders, are handled appropriately. Using Nginx load balancer capability, you can configure one load balancer to send traffic to one or more backend web servers. Should you need to add more backend web servers, it's as easy as bringing that backend server and adding it to the list. A load balancer checks the health status of the backend web server, and if it can communicate with that server, it will not port any traffic to it. That way you can always confirm that your website is going to be running, right? Because if one node goes down, Nginx will simply just not forward traffic to the dead node, let's say. And as long as it has at least one node, your website will be running. Another use case is a reverse proxy. Suppose you have a package to deliver and you take it to your local post office, right? When you go into the post office, you don't hand your package directly to the courier drivers, right? You most likely talk to a clerk who will get the information about where the package is going and schedule the courier driver who will pick up the package and deliver it. The package in this case is the request made from your computer. The clerk is the proxy and the courier driver is the backend web server that will take care of processing your request. So every incoming request must go through the proxy, which will take that request and pass it to the appropriate backend web server. Best practices is that your backend servers have an internal IP address not accessible to the internet, meaning that the only way to get to those backend servers is to go through the reverse proxy. Now, I know what you're thinking. What's the difference between the reverse proxy and the load balancer? They're often used interchangeably, but they have a different purpose. So let's clear that out of the way. A load balancer's job is to distribute incoming traffic requests across multiple backend servers to ensure that no single server becomes overwhelmed. Its goal is to optimize the distribution of traffic, whereas a reverse proxy, in this case, its primary role is to act as the middleman between the user and the backend server. So a load balancer needs more than one backend node, whereas a reverse proxy could proxy traffic to a single node, as its job is not to load balance traffic, but rather proxy traffic to a backend server. Another use case, obviously, is the forward proxy. Suppose you have to run a public library, right? And inside this library, you have books, a few computer stations, and people can use to surf the internet. All of these computers get to the internet, but in order to protect minors from accessing potential harmful content, you would probably filter certain websites using a proxy and protect the client's online identity. Nginx can also be used as a forward proxy, and it's just like a reverse proxy, only backwards, or should I say forward. Instead of proxying incoming traffic, the forward proxy is controlling outgoing traffic. This can be used to block certain content, protect the client's online identity, because all traffic goes through this middleman proxy. Back to this coffee shop, right, that we talked about, right? Imagine you're running the same coffee shop and you have to grind the beans, brew the coffee, and prepare it from scratch every time a customer comes in. This wouldn't be very efficient, right? It might work for the first 2 customers, 3, if you're not busy. But as more customers come in, you're going to start to fall behind. Now imagine you prepare a batch of coffee that is ready on the counter for the next customer. When someone orders coffee, instead of brewing it from scratch, you just pour it into a cup. This saves time because you're not having to repeat the same process over and over. And that's exactly what a cache server does. It works in a similar way, but with data on the internet. A cache server stores a copy of the data, which is the batch of coffee in our coffee examples, so that subsequent requests can be served immediately from the cache server without need to pass on the request to the backend servers. Having cache prevents systems from processing the same requests over and over again. In the next couple of modules, we're going to be implementing a few of these, not all of them, but hopefully with that, you'll get a better understanding of all these really cool features. Now let's summarize what we learned in this first module. We talked about web servers and how you interact with them every single day just by surfing the internet, how all those requests end up in a web server that will generate that content and send it back to your browser. We learned about Nginx's popularity and how it was developed to compete against Apache and IIS, and how quickly it became one of the top web browsers that is used today. We learned about the open source version of Nginx and about the commercial base, which is Nginx Plus. You can install it anywhere, but remember Nginx Plus is the paid version. And we also had a look at Nginx performance and why it still leads the polls, and it's your go-to web server whenever anyone wants to configure something. So that's it for this module. I'll see you guys in the next one where we're going to actually start installing it. Thanks again. So let's dive into what we're going to cover in this module. First thing we're going to do is get a clear understanding of what package managers are, how they work. We'll go through some popular examples like apt install, yum install, homebrew, etc. Next, I'm going to show you how to install Nginx on different distributions. We're going to be using Ubuntu, but I'm going to show you how to install it in CentOS and in Mac OS X in Windows. Once we get that up and running, we will learn how to manage the services. So we're going to be using Nginx build commands to check status, starting it, restarting it, reloading, etc. We're also going to explore the structure of the nginx.conf file. Very, very important. And we'll walk through what the global settings are, server blocks, HTTP blocks, etc. After that, we're hosting a simple static website using Nginx. We're going to use our server blocks, and we'll serve some HTML content. We're going to also discuss what ports are, very important. We're going to be using UFW, Uncomplicated Firewall, and we're going to protect our website using this firewall. In this video, we'll cover the basic configuration of Nginx. So let's dive into the nginx.conf file, which is the main configuration file for Nginx. You'll typically find this in etc/nginx on most Linux distributions. Here's a quick overview of how it's structured. We first have what's called global settings. This is where you set up configurations that affect the entire Nginx server. Things like user privileges, number of workers, rate limiting settings, etc. Compression, cache, all of that. Next is the events block. This section is all about managing connections and threading. It controls things like the worker connections and event model and even connection processing. Don't worry, we'll go over all of this later on. And then we have the HTTP block. This is where you handle everything related to web traffic. It includes server blocks, which are like virtual hosts, along with settings for HTTP optimizations and security rules. Don't worry about looking at all this and not knowing what all this means. We'll go over this later on. And last, we have possibly the most important block, which is called the server block. This is the key part of Nginx. This is where you define how Nginx should respond to requests for different domains or subdomains. So understanding this block right here is essential to configuring Nginx effectively. Let's take a look at what a typical nginx.conf file might look like. Here's an example. So we have here those HTTP settings that we talked about, the events block, and the global settings at the top. This might or might not look the same depending on what distribution you have, but again, this is just an example. And now let's dig deeper into this. Let's break down what each of these mean. So the first one we have here is the user. This line specifies the user that Nginx runs as. Basically, Nginx will run the Nginx service as that user. In this case, it's set to www-data, which is a common user for web services. So you're using Debian, Ubuntu in this case, you'll see www-data. But if you're using something like Red Hat or CentOS, the user here would probably be something like Nginx. It depends. Then we have the worker processes. Here we define the number of worker processes, and setting this to auto lets Nginx adjust the number based on the number of CPU cores available, which is really great for optimizing performance. And then we have the PID, which stands for Process Identifier. And this specifies the location of the PID file, which stores the process ID of the Nginx master process. We will interact a lot with this PID when we pass in signals like reloading, restarting, shutting down, etc. Next is the events block, and this controls the network connections. Basically, the amount of simultaneous connections it can handle. It ties with the worker process that we just saw, the one that we set to auto. So in order to find out the total number of max clients, we need to multiply the worker processes, right? So that's set to auto, times the worker connections here that you see. So for example, a server that has 4 cores, for example, we would time that times the worker connections, 1024, and you would get a maximum of 4,096 clients that your web server could handle at any given time. And then we have the HTTP block. This is the main block, like I said. This is where all the HTTP related configurations reside. And in this block, you can configure things like log formats, keep alive timeouts, compression, rate limiting, other global configurations. Let's talk about creating and editing server blocks. They're also known as virtual hosts. And virtual hosts are the websites you configure on a web server. These server blocks are what allow you to host multiple websites on a single server, each with its own configuration. Think of the web server as a building, and inside this building, there are many companies. These are the websites. And a single server can essentially serve one or more multiple websites in the same way that a building can house multiple companies in the same building. So when a request comes in, Nginx uses the server name or IP address to figure out which server block to use, making sure that the right website responds. Let's take a look at an example of a simple server block, and let's try to break this down a little more. Here we have the listen directive. This defines the port on which Nginx should listen to. And this can be for port 80 or 443 HTTP or HTTPS, or it could be another port. It could be something like 8080 if you ever used something like Nginx, right? So it really depends on what port you want to listen to, but for the most part, if you're serving traffic to the public, you want to use 80 for unsecure or unencrypted traffic, or 443 for encrypted. Then we have the server name, and this is important because it handles the domain or subdomain in the name of the website users would type in their browser to reach your website. If you had more than one virtual host configured in this Nginx server, how would Nginx know what content to serve? The only way it could do that is by using this server name right here. So it's really important that you have a server name on all your configurations. Next is this root. This contains the directory for where the website's files would be. So in this case, it's /bar/www/example.com. And this is really with the default directory where Debian-based distributions would store it. But if you're using something like Red Hat or CentOS, it might say /usr/share//nginx//HTML. It really depends on what distribution you're using, but you can always find out the root default directory by having a look at the nginx.conf configuration files. And then we have this location block, and the / here represents the landing of the page. It's often called the root of the domain. In this example, it's example.com, right? So when you're landing on example.com, that's what that location block is doing. That location / directive, that's what it means essentially. It's when you land on example.com. And then below that, you can see that we had this try files. It's got a $URI space $URI /. And this, we'll talk more about the Nginx built-in variables, but this checks basically if the file that you're looking for or the directory exists, and if there's anything that comes after that, like / images or something like that, for example, foo or foo bar. And if it can't find anything, then you're going to get basically a 404 not found. We'll talk more about status codes later on. But when I look at this configuration, the first thing I see is it's going to land on example.com and it's going to try to find files. Now, below that root directory, you see that it has this index and index.html. That try files will look for those files in that root directory. And if it can't find them, it will give you a 404. But inside of this example.com directory, there could be other folders, and that try files directive here will try to find files that you're requesting. And if it can't find them, it will spit out a 404. Again, we'll talk more about that a little bit later on. So Nginx has dozens of modules, and each one of these modules has dozens of arguments and directive options. The HTTP core module, for example, has dozens of directives, including the server directive that we just talked about, which is in there. It might not be in the screenshot, but it's in there. We are definitely not going to go over every single thing. There's just not enough time. And there's a lot of modules, so it really depends on what you're trying to do. All right, so now let's dig into the Nginx directory structure. And the key configuration files you'll be working with here, first up is we have this nginx.conf file. This is universal across any distribution. It'll always be in the /etc /nginx /nginx.conf. And again, this is the main configuration file for Nginx. This is where most of your core settings will live. Next, we have a directory inside of that etc nginx folder called sites available. And here you'll find the configuration files for each website or virtual host you configured. Just keep in mind that just because you have a file in there, it doesn't mean that the configuration is active. So that's where you would need the next folder, which is called etc nginx sites enabled. In this directory, you have that symbolic link. It's also referred to as symlink to the file that is in sites available that you currently enable, I guess, in a way. If you want to use it, you want to put it first sites available, and then you will enable it, and it will add it to the sites enabled. It's a little bit different. So if you're coming from like Apache has a command, I think it's A2N site or something like that, that will enable a site. And then they also have the counter to its D site or A2D site to disable a website. I wish Nginx had something like that, but we use symbolic links to enable and disable. Now, if you want additional configuration needs, there is a folder called conf.d, and you could set up some SSL things if you want. You can also use it to set up some load balancing or just a extra directory to store extra configuration files. Now, we're not really going to use that folder through most of our demos, but I might be wrong. We might just use it. It's just not, you can store most of the configuration in all these and these three other directories. Now, when it comes to the actual website itself, they're usually stored in bar www. This is the Debian Ubuntu default, but if you're using something like Red Hat or Fedora or CentOS, it would be /usr/share/Nginx, and I believe it's /HTML on the default folder. We are going to be sticking with Ubuntu throughout this whole course. We just find that Ubuntu has a very friendly approach. It's got a huge community backing. So, just FYI, we are going to be using Ubuntu. Moving on, we have this folder called MIME types. This is where you would define these different file extensions, which helps the server understand how to handle various file formats. For example, how to handle text files, JPEGs, video, audio files, etc. For processing management, we have the Nginx PID file to store that process ID that I talked about. That's what passes that signal to the Nginx master processes. And finally, we have a folder called varlog Nginx. Very, very, very important. This is where our access logs are and our error logs. And this is how we keep track of what's happening in our website. So very, very important that folder. We will be having a look at that a lot. Now let's go over some essential Nginx commands that you'll find very handy. First, we have the Nginx-H, and this gives you the help menu if you want to do a quick reference and you're not sure about what the options are. We have Nginx-V. This gives you the version of Nginx you're running. So if you're ever in support and they want to know the information, what version you're running, or you want to maybe use a module and you're not really sure if it's supported on an older version of Nginx, this is how you would find out the version you're running. And then you have the Nginx-V, and this provides the detailed build of all your configuration. So this will give you all the modules that are currently installed. It'll give you the version of Nginx. It has a much more, detail on the output than Nginx-V, which just gives you the version. Now, the Nginx-T command is probably the most important command of any of these Nginx that you're going to use. And this checks your configuration for any issues, primarily syntax issues. We all make mistakes. You can add an extra comma, you can add an extra space, you don't add the semicolon, you put something where it's not supposed to. Nginx-T will catch those. So it's crucial that you use this every time you make a change, and you'll see throughout the demos, I'm always going to use Nginx-T because you don't want to make a change, save it, restart or reload Nginx only to find out that, you broke the configuration and you broke the website essentially. So very, very important. Then we have Nginx-T, and this is particularly helpful when you're seeking support and they want you to share the configuration. So let's say you have support, support might ask you for a whole detail of that configuration. You would use Nginx-T. Ngin-S. This is that signal to the master process. So with this, we can do a lot of things. We can stop, we can quit, we can reload, we can reopen. For example, if you wanted to stop Nginx, you could do Nginx-S for signal and then pass in the stop command. If you wanted to do the same thing with quit, reload, reopen, you're always going to use Nginx space -S space, reload, for example. And the reloading, I should mention that the reloading is much more friendly than the restart. Restart will actually restart the Nginx service. Reload just reloads the configuration. So again, back to Nginx-T. If you want to make changes, make sure that you run Nginx-T first, and then you reload. So you would do something like this. You would do sudo space Nginx-T. If you get the successful response, like here, you can see here that says syntax is okay, test successful. Now you can go ahead and reload, and you should have no issues. You could also restart Nginx, right? Now I said that Nginx-S space reload is safer than restart, but there are some times when you need to restart Nginx. This is the way you can do it. You can also reload Nginx, right? This is safer than the restart. Essentially, this is systemd doing the reload as opposed to Nginx reloading its configuration. It's not the same, but it's safer than the restart. And you can also check the status of Nginx. That about wraps up for this overview. Before moving on to the steps of installing Nginx, we need to understand a term called package manager. A package manager is an automation tool. It takes care of the whole process of installing, upgrading, configuring, and even removing software from your machine. Think of this tool that handles all of the details, like downloading the software, sorting out dependencies, and managing everything across your system. Package managers are really important in modern operating systems because they make managing software so much easier than following manual steps. They also keep everything up to date and ensure that a system is always properly configured. Here's how Package Manager works. It starts by pulling software packages and their details from these centralized repositories. These repositories are often maintained by the operating systems creators, third-party developers, and open source communities like Nginx Open Source Core, for example. When you choose to install a package, the package manager automatically checks any other software known as dependencies. If any dependencies are missing, it grabs those too, ensuring that everything works smoothly together. Once all the necessary pieces are in place, the package manager might also help you configure the software, either during the installation or after the installation, so it fits perfectly with your system setup. The whole process from fetching the package to resolving the dependencies and setting up makes managing software efficient and reliable. Let's talk about some popular package managers that you might have come across. First up is APT, or Advanced Package Tool. And this is the one we're going to use because we're using Ubuntu. Debian also uses this, and this is going to be our go-to package manager. It works with the .dev packages and really simplifies the whole process of installing, updating, and removing software. For example, you could do sudo apt update to update your package list. You can do sudo apt install package and then the name of the package to install a new package, and even sudo apt remove and then the name of the package to remove the package. You could also do sudo apt upgrade to make sure everything is up to date. And if you wanted to search for a package, you could use by using sudo apt -cache search and then the name of the package name. Next, we have Yum, which stands for Yellow Dog Updater Modified. And this one's used by Red Hat and CentOS, Fedora, and deals with the RPM packages and automatically handles all those dependencies for you. You need to install something, you just run sudo yum install package, and then obviously the name of the package. If you want to remove something, likewise, you do sudo yum remove in the name of the package. If you want to update everything, sudo yum update. This pulls all those changes from the repositories. And if you want to search for a package, sudo yum search and then the name of the package. It's that easy. If you're on Mac OS, even Linux, you probably heard of something like Homebrew. It's an incredible popular Mac OS package manager, and it works on Linux too. Homebrew installs software right from your home directory, so you don't even really need any sudo privileges like you would using, yum or up. You can update package list with brew update. You can install software with brew installed in the name of the package. You can remove it with brew uninstall, pass in the package name, and you can also search for a package and see what's available. Pretty easy. And finally, for all those Windows users out there, we have something called Chocolatey. And this package manager automates software installations right from the command line. Super handy, and managing all these installations across multiple machines if you wanted to. To install something with Chocolatey, you would use choco install and then the name of the package. And if you want to remove it, you would do choco uninstall and then the name of the package. These package managers are very powerful tools, and they make managing software much easier than doing it manually. So always use a package manager to install any packages unless it's not available. For example, if you wanted to update your package, if you wanted to install Nginx, I should say, you would first do sudo apt update, and then we do sudo apt install Nginx. If you wanted to do on Red Hat or Fedora, sudo yum update and sudo yum install Nginx. I should mention that I'm not passing the -y in here on the Linux command, so Ubuntu and Red Hat. You would probably want to do sudo apt update -y to avoid that prompt. But if you don't pass it, you just have to type in Y when it prompts you for yes or no. There's OSX, brew update, brew install Nginx. And if you want to do for Windows, choco install Nginx. On the next part of this module, we're going to do the demo. I'm going to show you guys how to install Nginx. Now I would like to demonstrate how to install Nginx. Now I am using an Ubuntu distribution here, but if you're using something like Debian, CentOS, or Red Hat, these steps should more or less be the same. Instead of using apt, you're probably going to use yum. That's for CentOS and Red Hat. Now we're using Ubuntu here, so I'm going to stick with the apt update and apt install. The first thing we want to do here is run sudo apt update. And what this is going to do is it's going to update the package sources list with the latest versions of the packages in the repositories. Now, I do want to add the -y, and this will skip the prompt for yes or no. And it's going to pull all the latest changes. And this is useful because if you want to install a package, you want to install the latest version. And by running apt update, you are ensuring that you're going to install the latest available version. I'm going to go ahead and clear the screen here. And now I want to install Nginx. So we're going to do sudo apt install Nginx. And I'm not going to pass the -y just so you can see what happens. And of course, I'm immediately prompted for a yes or no to continue. I'm going to say yes. And you can see that it's installing a lot of dependencies, a lot of packages. This is perfectly normal. I'm going to go ahead and clear the screen again. And now that we've installed Nginx, we need to verify if the service is running. And we can do so by using systemd. So we're going to do sudo systemctl status Nginx. And we can see here that it's inactive, it's dead, so we need to start it. We can do so by rerunning the same command above, but instead of running status, we're going to do start. You could also pass in stop if you wanted to stop Nginx. So I'm going to go ahead and start it. And now I'm going to rerun the status command to see if it's running now. And here you go. There's a lot of information here. Don't worry about that. What we really want to focus on here is the active running. And it's running. So I'm going to go ahead and clear the screen again. Now that we know that the Nginx service is running, we need to confirm if Nginx is responding. And we could do so by using the curl command. This CLI tool is useful to test web servers, API endpoints, and we can interact with it. So we're going to use curl localhost. Localhost here is the system that we're on. This Alpine host is the local host. So it's going to make an HTTP request against the system. And if there's a web server behind, we should get a response. So I'm going to go ahead and press enter. And you get the default welcome to Nginx page that's included in all of the Nginx installations. I'm going to go ahead and clear this. Now we know that the Nginx service is running and we know that Nginx is responding as it should. Now I want to head over to the etc Nginx folder. Across all distributions, the etc folder is always used for system configuration files, so you can be sure you can find the Nginx configuration files in here. Now I'm going to list the files here. There's a lot of information in here. We're going to go over some of this, but don't worry about all of this for now. What I do want to focus on here is the nginx.conf file. This is the global settings. So I'm going to go ahead and open this file. We went over some of these things on module 1. Don't worry about it. We're going to get into more detail as the course proceeds, of course. You can see here we have the HTTP block, which is the global settings. If we hover a bit down here, you can see the login settings. Now, this is where, if logging is enabled, this is where by default it's going to write the logs to. So var log the Nginx folder, and you'll have an access or an error log. If we continue going down, we could see here the virtual host configurations. This include here is very important because this is what Nginx will use to read any configuration files it needs to. You can see here that we're saying include etc nginx conf.d. So everything in this folder and anything that ends with the extension .conf. This star here, this is the wildcard. Basically, it means anything .conf, and it will read that file. We can also see the second part of this is to include anything under the sites enabled. Now notice that the sites enabled doesn't have the extension .conf. That means that it will read any configuration here. So it's very important that we verify that the syntax is correct and that our configuration files look good before we try to reload Nginx. If you continue going down, you could see some examples here of the server blocks that we talked about. I personally don't put server blocks for any websites inside the nginx.conf file. I save those for the sites enabled, sites available. You could put them in here, but best practices is that you make a single configuration for each of the websites you plan to host on this server. So I'm going to go ahead and quit here because I'm not going to make any changes. And I will show you where that var log nginx folder is. Right here. And if we do an LL here, you can see that we already have the access log and the error log. It has nothing right now written to it. So we just installed it, so there's nothing in here. But as you configure your websites, you will see the logs in here. Now there might be a directory under here based on the name of your website, for example. And then inside of that folder, you would have the access and error log if you enabled it. But we're going to go over that in the next module, which we're going to be setting up 2 websites so we can hit and we can test how to configure the virtual hosts. So in this module, what I like to do is go over a hello world example. As of course, it is tradition to always start with a hello world. So why not follow the same suit and do it here as well. Now, the first thing I want to do is make sure that Nginx is installed. So I can do a sudo system ctl status Nginx. It hasn't started or it's not started. So let's go ahead and start it. I'm going to clear this screen and I'm going to just verify that Nginx is running by doing our curl command, curl localhost. And we can see here that Nginx is responding with the default welcome to Nginx page. Now, what we want to do here is we want to copy the same configuration that this default page is using, and we're going to modify it to our needs. I'm going to go ahead here and clear the screen, and I'm going to head over to etc Nginx. Here are the files. And what I want to do is become root so that I don't have to type in sudo each time. So I'm going to do sudo su, and you can see right now that we changed from Bob to root. I'm going to clear the screen again. In this directory, there is a folder called sites available. So let's change directory into sites available. I'm going to clear again. list of files, and you could see the default configuration file. This is the configuration that is currently serving that default welcome to Nginx application. So let's go ahead and copy this file, and we will name it something like hello world. So let's go ahead and do copy default to hello world. Okay, just like that. And now if we display it, we can see the hello world here. So I'm going to clear the screen again, and I'm going to open up the hello world. And we're going to remove a lot of these comments. When you see a hash here, it's a comment. You can delete this. You can leave it there. I'm going to delete it so we can have a better view of the configuration we're going to create. I am going to remove all these blue ones right here. We don't need them. And in fact, I'm going to delete the IPv6 here. I'm going to head down here and remove all these comments in here and keep this as simple as possible. Delete all these ones right here. This gives you some examples right here. And here we go. So this is what I'm going to keep in here. Now, the first thing I want to do here is talk about the server name. At the moment, in our welcome to Nginx default, you could see here that this is empty. It has no server name. Now, when you want to host a website, you need to pass in the name of the website that will be serving this content. So in this example, we are going to do hello world, helloworld.com. And that means that whenever a request is being made to helloworld.com, Nginx will serve this content. It will look at the server name. It's actually a header that I'm going to go over in a little bit. It's the host header, and it'll match the helloworld.com with this configuration. The next thing we want to go over is the root directory here. This directive here tells Nginx where to look for the HTML, the JavaScript, CSS files. So the current directory right now is for that welcome to Nginx default. So we are going to change this, and we are going to call this, or we're going to rename this to hello world, and I'm just going to leave it like that. Now we are going to have to create this folder, but let's stick to the Nginx configuration first, and then we'll create the rest. So now when traffic is going to come in at helloworld.com, the first thing Nginx is going to do is it's going to try to read files from this root. And the first thing that it's actually going to try to do is read an index or index.html file. This defines the file that is to be used as the index when you land on the website helloworld.com. Something has to serve the front page, and that's where we're going to use our index.html page. Now, the rest of the things, you can leave it for now. We'll leave this as is. We will talk about this a little bit later, but I am happy with this configuration. I'm going to leave it as is, and I'm going to save my configuration. And now what we need to do is we need to create the directory that we just mentioned. So I'm going to head over to var www. I'm going to list the folders here. And this is the HTML folder that contains the default welcome to Nginx. Again, if we do curl localhost, you could see that configuration. Sorry, that content, this HTML. I clear again here. And what we want to do here is we want to create the same directory as we spelled it in our configuration. And that is going to be mkdir hello world. That's it. Now, if we list the folders here, now we have an HTML folder and we have a hello world. I'm going to go into the hello world and it's empty. There's nothing in here, but remember that we need an index file here. So I'm going to just create a quick one. I'm going to use the touch command to create a file, index.html. And I'm going to go into this file, some basic HTML, and we're going to do hello world. We're going to close. our HTML tag right here. I'm going to save this. And now we have, if I go back up one directory, we have both the HTML, which is the default, welcome to Nginx, and now we have our hello world. Now, with that created, we can go back up to Etsy Nginx. Etsy Nginx, clear the screen again, do an LL. And the last piece right here that we have to do is create a symbolic link from sites available to sites enabled. So if we have a look at sites enabled, you will see here that this default is actually a link to Etsy Nginx sites available default. So we have to create the same for our hello page that we just did. So if we do sites available, you can see here that we have our default and we also have our hello world. So let me clear the screen again, and I'm going to go into sites available, list them, and now we can create our symbolic link. And this is the command ln, and we're going to pass in the -s for a symbolic. And we have to be specific of the whole path of where this is. There's the source and the destination. So I'm going to do Etsy Nginx sites available hello world, and it's going to go into Etsy Nginx sites enabled, just like that. I'm going to press enter. I'm going to go up one directory, and now I'm going to list the whole configurations in sites enabled. Sites enabled. And you can see now that we have our hello world, which is a symbolic link to the Nginx sites available hello world. Now, with that out of the way, the next thing we need to do is make sure that we check for any syntax errors or any errors at all. And that's where we can use the Nginx-T, -T of course being for test. And it failed. It actually gives me something and it says, hey, there's a duplicate default server in here. So we need to remove that line. I kind of forgot, but I'm glad that it happened so you guys can see that you cannot use the same duplicate default server under two websites. So I'm going to go into sites available. I'm going to do hello world, and I'm going to remove this default server here and just leave it empty, right? And I'm going to save that. I'm going to rerun the test, and now we get our successful. So now that we configured our new hello world test page and we created a folder, we ran the Nginx-T to check for syntax errors. Now we can reload it. So we're going to do Nginx-S. This is a signal to reload. And that's done. So with that being done, I'm going to clear the screen. I'm going to exit the root account. I want to go back to being Bob. It's not really a good idea to continue using root for everything. So now what we can do is test Nginx again using the curl command. So we're going to do curl localhost. And I just want to show you what happens and how Nginx responds. So here we're going to get the welcome to Nginx default webpage. But how do we get the hello world? And that's where we use headers. Now, normally, what we would need to do is create a DNS record, right? When you go into something like google.com, for example, you don't remember the IP. You just remember google.com. Now, in our helloworld.com example, we would need to create a DNS record. It would need to propagate, and it could take a little while. But what we could do is we can use the curl command with some parameters to pass in the host headers. And I will show you what that looks like. So we are going to do curl, right? And we're going to do -- header. And in double quotes, we're going to do host : and we are going to do helloworld.com against the local host. And this, if it's set up correctly, should respond with our hello world page. So let's give it a shot. And there you go. We get the hello world. Again, this is a very basic response. This is not really the a real website, but just to show you how to set the server name in the Nginx configuration and also how to test it internally. Now, look what happens if I try to pass in a bogus DNS name. Let's do hello KodeKloud. And notice that Nginx still responds, but it's not responding with anything to do with hello KodeKloud, right? Nginx will serve the first available configuration when it cannot match. And what I mean by that is, I'm going to go ahead and clear this. Let's go into sites enabled, do an LL here. So if I go back to the command that I did, curl header host KodeKloud, what Nginx will do here is it's going to try to match this hello KodeKloud into one of these configurations. And if it cannot find one, it will serve the first one available alphabetically. So because there is no such thing in my configurations as hello KodeKloud, it's going to serve the default one. That's why in most cases, when you're setting up Nginx, you would most likely want to remove the default configuration. But again, Nginx will always serve the first available configuration alphabetically, and it will serve that configuration. So it's important that you set your server name correctly so that you don't run into these kinds of issues. So again, I'm going to fix it and do hello world.com. And now we get the hello world. Now notice that it has to be specific. It cannot be just hello world. It needs to be helloworld.com because that is what we configured it in the configuration file. So I'm going to clear again. Let's have a look at hello world. And this is the server name that we used. Now, there's one more thing here that we haven't done, and that is testing this from outside of the terminal. All this time we've been using curl, localhost, passing in headers, but now we need to test this what a client would see if they were to open up this in the browser. Now, at the moment, we cannot do that because we don't have a firewall enabled. You always want to have a firewall enabled. So on the next demo, I'm going to be going over the software firewall for Ubuntu and showing you how to open up a port so that you could serve the traffic to users. So what's a firewall? A firewall is a software security guard that can be used in a computer or a server. It acts like a barrier between your system and the internet to protect you from potentially harmful threats. A firewall monitors the information that comes in and out of your computer network. Think of a firewall like a home security alarm system. The monitors when doors and windows are opened. And if an intruder breaks in, your alarm should kick in. It's also worth noting that the firewall can also be a hardware device that does pretty much the same thing as a software firewall. You would only really ever use that if you're running a data center. Debian and Ubuntu distributions come with a firewall, and the configuration tool is called UFW, or Uncomplicated Firewall. This firewall is not enabled by default, which means that all traffic is allowed to enter freely without any restrictions. And you should probably enable it as soon as possible and only allow certain traffic to come in. Likewise, Red Hat and Fedora also come with a firewall, and that tool is called Firewall D. This firewall is also not enabled by default, follows the same idea. You want to enable it and only whitelist certain traffic from coming in. In the event that it's not installed, you can do so quite easily by just running the yum install package manager, and installing Firewall D. It's also worth noting that both UFW for the Debian-based distributions and this Firewall D for the Red Hat distributions are really just the front end for IP tables. IP tables is another tool that is a lot more complicated, and it basically opens and closes ports. So these tools are the simplified tools that are the front end for the back end, which is really IP tables. Windows and OS X also have their own firewall, I should say. They can be turned on and off. Windows firewall is enabled by default, and I think OS X, it's disabled by default, but you can enable it. In fact, always enable your firewall. So ports, what are they? A port is a communication endpoint that allows data to flow in and out of a computer or a network device. Think of a computer as a house and ports as doors and windows. For security and peace of mind, you would most likely lock your doors and maybe open a window here and there. You would also have a home security alarm that will notify you if a door is left open or if a thief breaks into your house. When you use the internet, you're interacting with a lot of services. If you're using any browser, for example, any website, you're most likely communicating through a port called 443. If you're trying to remote desktop into a Windows computer, you're interacting with a port. As you can see, the ports, these are the most common ports that we see right here. So just a quick overview here of some of the most commonly used ports. You don't need to memorize them all, but you do need to know the first two, which is HTTP and 443. In order to serve your website safely in the internet, you want to enable the firewall and open HTTP and HTTPS ports. There is almost no reason to ever open anything other than HTTP and HTTPS on the internet. And if you do, you can always whitelist those IPs so that only those, IPs are allowed instead of allowing that across the public and potentially getting a hacker or, some vulnerability hit you. For Debian distributions, you should first open SSH ports and then enable it. It's important to do this because if not, you will lock yourself out. So this is the way that you would want to enable ports. You would do UFW allow port number and then /TCP, and then you do UFW reload. You can also close ports, UFW status numbered, and then UFW delete, and then the number of that rule. UFW doesn't really have a command that will sort of say, hey, delete, 22 TCP. You have to delete them by numbered. It's kind of a tedious task, but it's not so bad. And you can also check the status. This gives you a list of the rules that you currently have. So it'll show the ports that are currently open. With Firewall D, similar. If it's not installed by default, you can install it running the yum update and the yum install Firewall D command. You can start it and enable it. The first command here will start the Firewall D service, and then the second command will enable it on startup. Basically, what it will do is next time the system gets rebooted, Firewall D will start right away. So you won't have to start it manually next time. Likewise, you can open and close ports. To open up a port, you can do firewall-cmd. You add the --permanent --add port and the port number /TCP, and then you would reload it. With Firewall D, there is a lot more typing than UFW, for example. But the closing ports is a lot easier. You don't need to do any of that status number. You just pass in the remove instead of the add port, and that's how you can remove that port. And you can also do the status. Netstat, this is a very powerful tool that allows you to display active connections, ports on which the server is listening. You can install it easily by doing apt install net tools or yum install net tools if you're using Red Hat, Fedora. And you can see here in this command, We run a sudo netstat -nltup. All these parameters, one is to list, the other one's for TCP, UDP connections, show the port, etc. This command gives you a lot of information right here. It tells you that port 22 is listening, and let's say that we added, UFW allow 443 or 80, or if we use Firewall D, CentOS, whatever. It doesn't matter. Netstat will list only the ports that are currently listening, not the ones that you have opened. So if you're ever having any issues, Netstat is a really cool tool that will allow you to troubleshoot things a lot easier. Now let's get to the demo so we can see more about Firewall. Now in our last demo, we tested Nginx through the CLI. We used curl localhost to confirm if Nginx was working and if it responded. However, that's from the developer engineer point of view. That's what you would do if you were trying to troubleshoot inside of this Nginx server. Now, what about the client? Notice that we didn't use the browser to confirm. And that's because we could have, but I wanted to talk a little bit about UFW for Ubuntu, which stands for Uncomplicated Firewall. And we already talked about what a firewall is and why it's important. So let's just quickly go over this diagram to show you what we're going to be doing. So on the left here, we have our clients. They're going to be connecting in through the internet. And in this system, we have an Nginx server running that has the welcome to Nginx default page. And we also have a Flask application. It's a very basic application. Nginx is running on port 80. We could run it on port 43, but we don't have certificates, so we'll stick with 80. And we have a Flask application that's running on 5000. Now, at the moment, because the firewall is inactive, we should be able to hit these endpoints from a browser. So let's go ahead to our terminal here. And you can test quickly by doing curl localhost, right? That's the Nginx. And if we do port 5000, which is where this Flask application is running, I should get a different response. And here we go. However, again, this is from the engineer point of view inside the CLI. But what about the users? I'm gonna go ahead and clear this. If I head back into the options for our labs, you'll notice that we have these 3 dots in here, and we can click on view port. Now, if you want to view a port, you can just type in the port, right? So we're going to do port 80. We're going to open a port. There's welcome Nginx. And let's do 5000 for the Flask application. And there you go. That's it. It's as easy as that. However, this is not best practices. Best practices is we always enable our firewall and we only open ports that we need to. So in this case, let's open port 80 and port 5000. So the first thing I'm going to do is do sudo UFW status. And you can see here that it's inactive. So let's go ahead and enable that. So UFW enable. And what this does is we'll activate it, and it will also enable it on startup. So when you restart, the firewall is going to be enabled. Now what we want to do is add our rules. So we'll do sudo UFW allow 80. It's a TCP. And we're going to go ahead and say yes to that. So now if we run the status command again, we only see one rule here. Well, 2 rules for the same port. Port 80 is allowing anything to come in from anywhere. You can see here that the action is allow, and it's from anywhere. And it's coming from IPv6 and IPv4. So think of IPv6 if you had customers that are using their mobile, then this rule would be really important. So now let's go back into our other tab and test the view ports. So now let's test 80. This should work because we opened the port. And now let's 5000. And it'll just spin there. Now remember that it used to work before we enabled our firewall. So that means that our firewall is working as expected. So now if we want to open port 5000, we can do the same thing. Sudo UFW allow 5000 TCP. I'm going to clear the screen here, run the status again. And now we have 2 rules here. Well, 4 rules for 2 ports. I'm going to go ahead and test this again. Now we're going to test 5,000 and it should work. I do want to mention that one of the ports here that you definitely must always add is SSH or port 22. And the reason for that is that if I was to exit this SSH connection that I have right now connected to this Alpine host, what would happen is that the firewall would block that request on port 22 because it's not part of the list. So let's go ahead and allow this. Now we're not going to test 22, but just to show you, we're going to do that. And let's run the status again. And now we have port 22, we have port 80 and port 5000. So that means that if we exit this connection, we can SSH back in and we should be able to. Now, I do want to point out here that making a website available on port 5000 is not a good practice. If you think of all the websites that you visit, google.com, facebook.com, it's always .com. There is no ports that you need to add. Now, our labs allow you to just, this is a backend thing, but this port 5000 right here, it's opening up without any ports needed added in here, right? And actually, it's in the DNS name, but if you can see here, we're going through HTTPS. Now, this is just in the way that our labs are configured, but rest assured, if you were to use something like example.com, you would have to pass in this port in order to see that. Now, it's important that you don't make any websites publicly available on anything that's not port 80 or 443, because a lot of people will not remember to add a port at the end, and you're just opening up any attacks that potentially can come to your server. So it's important that you only allow 80 and 443, which is HTTP and HTTPS. You allow 22 or SSH, but we can whitelist just particular IPs, for example, our VPN IP or specific users' IPs. So that way 22 or SSH is only open to the chosen few, but for port 80 and 443, we can definitely open it up to the public. Now you might be wondering, okay, well then how do I expose my Flask application if you're telling me to only open port 80 and 443? Well, I'm glad you asked that or you thought of that, because that's exactly what we're going to be talking in another module when we start talking about reverse proxy or load balancer, which is a feature that Nginx comes in. So for the moment, just remember, only open ports that you need, and always make sure that you enable your firewall so that your server can be secure. And that brings us to the end of this module. Thanks again for joining us, guys. So let's summarize what we learned in this module. So we learned about package managers and why it's a good idea to use them. Now, I didn't cover how to install Nginx by compiling it. I don't recommend this. That's what package managers are there for. They make installing and removing packages a lot easier. So unless you really have a good reason, I would stick with the package managers. We learned to install Nginx on different distributions. Now we are going to be sticking with Ubuntu throughout this whole course, but the process of installing it is very similar across any platform. Now, if you want to test something on Windows or Mac OS X, that's fine, but I would never suggest using this in a production environment. Most, if not all, of production Nginx servers are running in a Linux distribution. We learned about Nginx and its built-in tool to manage operations, the Nginx-S for signal, so we can pass in the stop, start, reload, etc. We went over the nginx.conf, the global settings, the HTTP block, the events, and the server blocks as well. We learned that Nginx does serve static files very well, and you're able to use it and host multiple websites in one Nginx server using multiple server blocks. Now remember that you do want to pass in a server name there. If you don't pass a server name, Nginx will just pick up the first configuration available alphabetical order. We learned how to customize an Nginx default page and how to create our own, right? Just that hello world. It's that simple. It's simple HTML tags. And we also went over the importance of a firewall and port management. Now, it's crucial that you always enable your firewall in your Linux distribution and that you only allow the IPs that you expect to have traffic from. Now, port 80 and port 443, those are perfectly safe to keep it open to the public if you intend to make your website public. If you don't, I would just whitelist my own IP and just test it on my own. That does not cover the cloud security groups or firewalls that you might have with GCP, Azure, and AWS. Those are separate firewalls, so make sure that you pay attention when you make a firewall in one of the cloud providers that you also match that on your firewall software. If you're using CentOS, Firewall D, or if you're using Ubuntu, UFW. Thanks again for joining me in this module. You've earned a nice break. Get a cup of coffee. I'll see you guys in the next one.